Now I request Dr. S.K. Patil sir to felicitate today's guest, Dr. Thomas.
Hello.
Professor Dr. Thomas is a distinguished hydrologist with extensive experience in groundwater management, soil protection, and sustainable irrigation system. He has served in senior leadership roles at the Federal Institute of Georgian Natural Resources, Germany, including as head of the Groundwater and Soil Department. With a strong academic foundation, he completed his studies at the University of Karlsruhe and earned his habilitation in applied geology from the University of Berkeley. Dr. Thomas has deep expertise in groundwater exploration, remediation, and numerical modeling, contributing significantly to the sustainable resource management. He brings rich international experience, having worked across countries such as Afghanistan, Iran, South Africa, and Tanzania, advising governments and research projects. His work focuses on developing practical and sustainable solutions for water and soil conservation, especially in irrigation system. I thank you for gracing this occasion. I request you to talk your plenary session. So, can you just excuse me? Extremely sorry. I request Dr. S.K. Patil sir to felicitate our today's session chair, Dr. A.B. Kolekar sir. Now over to you, Dr. Thomas.
On? 1, 2, 3, 4, 5. Okay, it's on. Doctor. Yep, thanks a lot. Thank you. Yeah, welcome to everybody. My name is Thomas Himmelsbach. I'm a hydrogeologist by profession. I retired a year ago or so. And first of all, hydrogeology was my life. It is my life still. I'm still teaching at Karlsruhe University. So I give you some information about my things I have done, my projects and so. It was never boring, always interesting. Yeah. So I would like to start. Today I'm here on behalf of the Senior Expert Service in Germany. These are transferring internationally wide experience, knowledge about experience, sending experts to developing countries and not developing countries. So it's a wide variety of countries we have been visiting so far. And then I will just start with my presentation. I've entitled it Exploration and Development of Groundwater Resources in Southern Africa. So I've been visiting roughly about 12 different states in Africa during my life. I was head of the department at Geology and Soil Sciences at Hanover. And we have had a lot of foreign international projects where we started there. This is a summary of my experience. I'm talking about geological preconditions and perspective for the future use of groundwater resources. Why I have chosen this thematic area? Because it's also important for India. And if you look to the landscape and the climate, you will see it's quite comparable. Yeah. Yeah, we are talking first about the target areas. You see, we have been in the southern part of Africa. We have been in Namibia, Botswana, in Zimbabwe, in Zambia as well. So I give you some short examples out of these countries, and especially what we have done there. You see, water is one of the most important things in this area. This is one of our beaches. The third picture is one of our biggest success. Drilling a deep borehole, yielding an artesian aquifer at about 400 meters, and opening the well, it shoots up to 20 or 30 meters up to the air. Yeah, and you see, this is a dry area, but it can be is also affected by heavy rain, also comparable to India, which can flood everything. Yeah, in a few months it is completely dry again. Yeah, the Kalahari. So this northern part of Africa, in Namibia, and is living and settlement area of extremes. Yeah, we have extreme precipitation events sometimes with high floods, but we had also some droughts. And the thing is, so we have it's changing between long periods of droughts and long periods of precipitation. It's always going a sinus wave. Yeah. But at the moment, the droughts are becoming much more important because the frequency is decreasing. We have longer droughts and much more effective droughts. Yeah, I have taken a picture flying over the country. It was in 2019. It was the year of the most ever driest 3 months during drought period. Yeah. So you look out there, and normally it should have been raining started. The rain should have started, but it was only a few weeks after the so-called rainy season, the country was dry again, completely dry. And this is now the moment when groundwater comes into the scene, because groundwater resources, especially deep groundwater resources, are the only reservoirs we can use for water supply in these areas. Yeah, the development of the southern Africa is affected, of course, by the climate change effects, and we have a great impact on the living conditions. Yeah, and we have to set up the questions: how were the climate conditions in the past? Yeah, and will it change in the future? In which direction will it develop further on? So, with regard to fast-growing population, so we have several questions. Do we have already according adaptation strategies? Maybe we have to adopt them to the new situation. And with regard to the use of groundwater resources, we have several possibilities to do. So the main strategies are groundwater exploration. Then another one is subsurface storage. And of course, we have new management strategies. Africa is the continent with the largest population growth. Why have I chosen this picture? Because it's very essential to know in which time period your population will double, increase. Yeah. So if you have 1% population growth in your country, the time for doubling is about 70 years. If you have 2% doubling of population, it's decreasing already to 35 years. And with 3% it's 23 years. So you see, we are an urgent need to explore new water resources. And groundwater is one of the most important things. You see here, looking for the comparison in Central Asia, in Africa, how the population in billions is going on. And in sub-Saharan Africa, it's really, really high. Yeah, if you talk about groundwater and semi-fossil or even fossil groundwaters, we have to talk about geology and climate periods on our Earth. So our ice ages in Europe, yeah, correspond to the pluvial times in southern Africa. So it was completely different than today, yeah. So it was green, it was wet. We had the ice in Europe, yeah. The Etosha Basin we are talking about on first hand is an intercontinental basin which does not have any connecting to the sea. The tectonical structure of the basin is a result of Cretaceous and early Tertiary movements. And since that time, it's completely clipped off from the Atlantic Ocean and the other sea. We have a strong sedimentation, started 6 million years ago. And we had at that time some different lake levels according to shorelines at about maximum 100 meters. You know this in the reddish color underneath there. You see that we have here, you can use it, the reddish color. It's nowadays a Etosha pan. 40,000 years ago, the lake had this size and was also already dewatering to the east. So the Etosha pan today is only a small remnant of the ancient lake levels. Yeah? And then the backward orientation due to tilting of the continent resulted that the major rivers such today, the Kunene River, is now flowing towards the western to the Atlantic Ocean. And the Kunene and Kubango, they are dewatering to eastward. Yeah? Today, the Kubango and Kuito rivers are flowing into the Okavango Delta. You have to look at the sedimentation profile because the sedimentation profile in this area is some sort of a geological historic record. Yeah? We have to map them. We have separation of stratigraphic units, which can be mapped by sedimentation units. And it's a very important information about the sea levels. Yeah, we know, meanwhile, the sea levels did not reach more than 1,100 meters above sea level. An eldest lake level could not be defined. Also, the absolute age dating, we come later to this, is of the eddy sediments is impossible. But we have a thick clay layer with fossils prove a maximal water depth of approximately 60 meters. Yeah? And the sedimentation process was interrupted several times and the lake felt dry. And we have a high amount of sedimentation which was blown out of the salt and was repeated over a wide area. Why I do tell you this is the next picture. You see, nowadays we have again here the nowadays Etosha pan, and you see how the tectonic movement of the subsurface influenced the dewatering of the entire area. So the recharge came from Angola, in the high mountain, 2,500 meters high, much wetter climate. Nowadays it comes and you see the Kunene is flying towards west into the Atlantic Ocean, and the other dewatering is going into the Quito Okavango, and finally in the Okavango Delta it's going towards Zambia. Yeah? So in the Etosha pan is no more water arriving there. Yeah, where to look for water? We go back again in geological history. So we are looking for the sediments. The Kalahari sediments consist of huge sedimentary fans. And these huge sedimentary fans are a target for hydrogeologists to drill in, yeah, and to look for water. So the Kubango megafan is overlaying the elder Kunene megafan is not so important. But we have found out that these areas are huge. Yeah? And again here you see the Etosha pan. In information, in northern Namibia we have the highest population density and therefore the also highest need in water supply in this area. And this, of course, we found these findings are very important for the groundwater exploration, which started at BGR, where I was head of the department, nearly since 20 years earlier. It started exploration. Yeah, how it went. So we made a lot of drilling campaigns. Yeah, first to drill. And we are drilling there, and we go drill through the first aquifer, which is salty, we drilled through the first clay layer, which was impermeable, and drilled further on. And I can still remember a phone call which received me early in the morning of a colleague who was supervising these drilling methods. Said, Thomas, we have found water. I guess we have found a lot of water. Because the water was shooting out of the drilling machine, come out. Like in oil and rig gas. Gas. And of course, we did here a lot of raster electron microscope, and we looked at it. And it's not only for determination of age, it's also for the determination of the environment, the former environment. And we got some paleontological elements there, animals, which are clearly indicate it was a freshwater environment. So it's very important. So the climate conditions at the time, our ice age were completely different. The climate was warm and very humid, due to these microfossils. I show you some impressions of our groundwater sampling campaign in 2019 when we drilled into it. So at this time we brought a lot of technical instruments to Namibia. You will see we talk a lot about gas samplings, water samplings, isotope samplings, everything. So we realized that nearly every method which is available in hydrogeological science. And the sampling was of groundwater, of course, and gas, both. And you see how it works. So we pump water out of it, and it's filled in small tubes. They are sent to the laboratory, and for further investigations in Germany. It's a lot of effort to get this, but we got a lot of samples out of it. So coming to the results first. So stable isotopes. I don't want to go too much into depth. This diagram shows clearly, so more than 90% is going directly into the evaporation. So only a very small amount of water was going down at that time into the subsurface. And of course, it's a very important information. When you see also the two nowadays evaporation line, meteoric water line into evaporation. So most of the water is going in directly into evaporation. Then we were looking for the radiocarbon dating. Right, the mean half-time of 14 carbon is about 5,700 years. And you have to look for the concentration you detect there. Actually, we reached the frontier of science. So it was the largest, eldest thing we could even determine is about 5,100 years ago. And we did a lot of sampling there. We were talking about the sediments and also the groundwater and compared all these elements. But then we had a very interesting result. After several of these dating and drilling results and compiling them, we saw by investigation of radioactive 14 carbon and nitrate content of a deep groundwater, we found a very interesting coherence between these two processes, because you see here that the nitrate concentrations, so nitrate is due to evaporation, were much higher in earlier times, whereas in the elder times were lower. It's a direct indicator that the humid climate does not have so much nitrate. So the water that we were looking for is fresh, and it was it was going into the subsurface when there was a humid and wet climate. So different groundwater recharge under different climate conditions indicates strongly that at that time we had a lot of precipitation. Okay. Now I want to go further. Is a water play from the shallow aquifer. Is how the water, how it looks like. So it's a surface water you can't use. It can use only by animals because it's salty. This is some picture about the drilling campaign when we drilled into it. The most important thing is here, at this side, you see the freshwater horizon, roughly about 300 meters below surface. And then we started a huge trolling campaign, a lot of it with geophysical measurements and borehole results. And at the very end, you see these bluish is a paleo delta. It turned out to be a huge, really huge aquifer. And of course, we made an analysis of drill cores and everything. You see that we have there are animals that were living into the environment. And we plotted it together on plots, and we got some first idea, three-dimensional idea about how the aquifer is formed. Yeah. And then is first successful drilling in the Drip aquifer. It was near a school. We had sampled the water there. And here you see how it works. Here we have a schematic sketch of groundwater layers. We have a deep freshwater aquifer. We have a hydraulic separation barrier. We have the salty aquifer. We are found now the fresh groundwater in depth more than 240 meters. Next question, recorded, how we did it detected. We were using satellite imageries, and we are looking for the ground movements. And we clearly indicate that we have infiltration processes during humid times, and we have going soil lower off in drought times. So I will skip this, its time is too short. So we have another problem, reasons of nitrate enrichment in the upper aquifer. In the lower aquifer we don't have it. Yeah? And there you see climate and tectonic movement of the catchment area led to the actual arid areas. So at former days, the Okavango Delta was part of a huge lake, 300 by 600 kilometers wide. Yeah. This is what you see here, paleo lake levels, how they were in the past. And I want to end my presentation with some pictures of the helicopter we had in my department. So look, investigating large areas require aerial magnetics and aerial photography. We have there a helicopter. It's a very good engine and has a long endurance. And he's carrying aeromagnetic and electromagnetic sounds underneath his fuselage. And we have especially the electromagnetics of high importance, because we have a sound underneath the helicopter, which gives an electromagnetic pulse into the subsurface. And we're just recording the echo out of this element. And by the echo, we can determine about the resistivity and so on as of deep layers. We get a three-dimensional picture. Yeah? And this is a helicopter, how it is done. So we have a lot of instruments on board, even computers on board. And we have there the sensors under the helicopter. Yeah. Coming back to this, now to the summary. The new found deep groundwater formations, were detected in the beginning as lucky shots, just by drilling heavy or no saltwater lucky shots. And thus we have left the erratic strategy of simply drilling in boreholes and changed towards a knowledge-based exploration strategy. And which is used in the oil and gas industry. It's quite comparable, in order to get a better success. And so the large intercontinental basins in North Namibia contain deep semi-fossil aquifers, which are still connected to active recharge areas, but you have to treat them slowly. And the deep groundwater layers are now a strategic resource for the further development of the country and for a fast-growing population and easy adaptation to climate change effect. Now then I come to the end. Thank you very much for your attention. I took this picture. You see, water is life bottle store. It was a very intense rainy season, and in Namibia I took this picture. Thank you very much.
Thank you, Dr. Thomas.
Line fitting.
What's the?
In which you have done straight line fitting.
Straight line.
Straight line fitting.
Straight line fitting.
Just.
I guess you mean this, huh?
No, I think before 5-6 slides.